Railguns are a type of weapon that could truly change the world, for the better or for worse. Let's dive right in. What are railgun weapons? Railguns use electrical power instead of chemical power to propel projectiles over long distances at hypersonic speeds. A linear motor device, this weapon typically uses electromagnetic force to launch its projectiles. Such weapons will usually consist of two parallel conductors or rails, along which a sliding armature is sped up by the electromagnetic effects of a current that flows down one rail into the armature and then back along the other rail. A projectile is loaded in the armature, completing a circuit between the rails. It works on the same kind of ideas as a homopolar motor. However, unlike present-day artillery shells, railgun projectiles are just that, projectiles. They contain no explosives, rely on the kinetic energy imparted by the projectile, traveling 7 or so times the speed of sound, which can rip through steel or concrete, destroying anything in its path. After decades of research and development, railguns are still very much in the research stage, and it's still unclear if they will ever be used as real military weapons. Any trade-off analysis between electromagnetic propulsion systems and chemical propellants for weapons applications must also factor in the relative durability, availability, and economics of the weapons, as well as the novelty, bulkiness, high energy demand, and complexity of the pulsed power supplies that are needed for electromagnetic launcher systems. How effective is a railgun? By design, railguns are intended to be among the most powerful projectile launchers in the world. An electromagnetic railgun is designed to launch projectiles toward their target at velocities several orders of magnitude faster than the speed of sound. To illustrate, a prototype made by the U.S. Navy could launch its projectiles 6 times faster than the speed of sound. That's roughly 4,603.6 miles per hour, faster than just about any other weapon on the planet. A railgun's effective range is closely related to the speed at which it can launch a projectile. Land or ship-based railguns with Mach 6 capabilities are understood to have practical ranges of roughly 126 miles or 110 nautical miles at sea. The problems with building a railgun. The idea of a railgun, a weapon that uses electromagnetic force to propel a projectile over long distances, has been a topic of interest for militaries around the world for over a century. However, there are major difficulties that must be overcome before railguns can be deployed on the battlefield. One of the biggest challenges of designing a railgun is ensuring its durability. To date, public demonstrations have not shown the ability to fire multiple full-power shots from the same set of rails. While the U.S. Navy has claimed hundreds of shots from the same set of rails, there is nothing published to confirm that these are full-power shots and that the railgun is capable of firing accurately and safely. In order to be feasible for deployment, a railgun should be able to fire 6 rounds per minute with a rail life of about 3,000 rounds, tolerating launch accelerations of tens of thousands of Gs and extreme pressures and mega-ampere currents. A critical aspect of fielding a real railgun weapon is developing a robust guidance package for the projectile. This involves designing a package that fits within the mass, diameter, and volume constraints of the projectile and can survive high electromagnetic fields, surface temperatures of over 800 degrees Celsius, and plasma formation in the bore or at the muzzle exit. The package must also be radiation hardened and consume less than 8 watts of power with a battery life of at least 5 minutes. The goal is to have a production cost of less than $1,000 per unit. Recent advancements have been made in this area, with General Atomics Electromagnetic Systems announcing in June 2015 that projectiles with onboard electronics survive the railgun launch environment and perform their intended functions during tests at the U.S. Army's Dugway Proving Ground in Utah. The onboard electronics were able to measure in-bore accelerations and projectile dynamics, with the integral data link continuing to operate after the projectiles impacted the desert floor, which is essential for precision guidance. U.S. Navy's railgun development. The U.S. Navy announced at the end of 2022 that it was pulling the plug on its planned railgun program, sending 15 years of development and $500 million in research and development costs down the drain. Per the Navy's official statement, they intend to refocus their R&D efforts toward developing hypersonic missiles and directed energy weapons, as these weapons are already seeing limited deployment worldwide today. However, this might not be the only reason the Navy decided to move on from their planned railgun. Throughout development, the Navy struggled with making its railgun prototypes energy and resource efficient. Firing a single shot from one of these prototypes involved diverting massive amounts of power from the ship it was stored on. The Navy's railgun also suffered from another issue other railgun prototypes throughout history have gone through: poor reliability. Due to the sheer amount of force generated with each shot, the barrels or rails of a railgun wear out incredibly fast, making the gun less effective and less accurate over time without constantly replacing its parts. Despite its massive potential in naval and surface-to-air combat, perhaps the U.S. Navy couldn't contend with the railgun's numerous drawbacks. Due to how electromagnetic railguns work, many of these drawbacks are sadly unavoidable. These include the need for a source of powerful electrical current and enough room for the massive bank of capacitors needed to generate the charge. In addition, the current itself damages the rails every time the system is used, due partly to the tremendous heat generated and to arcing, which vaporizes the surface. The magnetic fields generated during launch can cause damage to nearby electronic equipment, so the ship must also be shielded, adding cost. It also takes some time to charge up between shots, reducing the number of rounds per minute that can be fired. A normal gun can be fired about 600 times before the barrel must be refurbished, but the barrel on the railgun prototype had to be replaced after about a dozen or 24 shots were fired. Matthew Karras, a defense analyst at consultancy Avison Group, said, "The railgun is, for the moment, dead, as the Navy cut funding for railgun research. The Defense Department is instead turning its attention to hypersonic missiles to keep up with China and Russia. The removal of funding suggests the Navy saw both challenges in implementing the technology as well as shortcomings in the projectile's range compared to hypersonic missiles," according to Karras. The Navy's decision to pause research at year's end frees up resources for hypersonic missiles, directed energy systems like lasers, and electronic warfare systems, said Lieutenant Courtney Callahan, who is a Navy spokesperson. She further added information gleaned during testing will be retained in the event the Office of Naval Research wants to pick up where it left off in the future. The technology was close to making the leap from science fiction to reality in the 21st century with the testing of prototypes. The concept held the possibility of providing an effective weapon at pennies on the dollar compared to smart bombs and missiles. That's because railguns use electricity instead of gunpowder, or jet or rocket engines, to accelerate a projectile at 6 or 7 times the speed of sound. That creates enough kinetic energy to destroy targets. A few years ago, the Navy was talking about putting the gun on the future warship Lyndon B. Johnson, the last of 3 stealthy destroyers. It's nearing completion and builder trials at Bath Iron Works. The 600-foot-long warship uses marine turbines similar to those that propel the Boeing 777 aircraft to help produce up to 78 megawatts of electricity for use in propulsion, weapons, and sensors. That's more than enough electricity for the railgun, and the ship has space following the cancellation of the advanced gun system, leaving the ship with no conventional cannon-based weapon. Instead, the Navy is pursuing an offshoot of the railgun, a hypervelocity projectile that can be fired from existing gun systems. A touch of history. While railguns sound like very modern pieces of kit, they actually have a long and exciting history. French inventor André-Louis Octave Fauchon Villeplier first introduced the concept of an electromagnetic railgun to the world with a functional, small-scale prototype of an electric cannon in 1918, and several weapons engineers worldwide took notice. They began work on their futuristic railguns. It wasn't until World War II that we saw plans for a fully functional, combat-ready railgun laid out. German engineer Joachim Hansler proposed creating what was essentially a railgun, an electromagnetically powered anti-airgun placement. This was to be an iteration of Villeplier's design decades earlier, a cannon that utilized a charged current to propel its projectiles forward. But that's all Hansler's idea ended up being, a design. Hansler's railgun was never built. Despite that, word quickly spread about this revolutionary new weapon design. The catch? Despite the weapon being theoretically possible, its sheer energy cost and operational requirements ensured that weapons of this type would not see development for quite some time. At the time, this hypothetical railgun would use enough energy upon firing a single shot to power half of Chicago at its proposed specifications. Since then, there have been multiple attempts by militaries around the world to get a working prototype out of the drawing board and into the battlefield. Perhaps the most recent and high-profile example of a military attempting to introduce an actual working railgun into its arsenal would be the U.S. Navy's $500 million railgun project. Although research and development had progressed enough to the point where several functional prototypes had been built, the U.S. Navy decided to pull the plug on its ambitious project. The future of railguns. Recent reports indicate that China intends to pick up where the U.S. Navy left off, with their own take on the railgun. They too have built and tested functional railgun prototypes out on the open sea. Now all that's left is to make it strong enough to withstand operational requirements. Chinese researchers have taken cues from previous railgun projects to develop a functional but also practical and efficient design. For instance, to circumvent the barrel wear faced by the Navy's railgun, they've run experiments using liquid metal, a highly conductive cooling material, to significantly decrease the wear and tear on the railgun's rails. According to their reports, not only could their railgun be much more practical than the Navy's, but it could also launch projectiles at higher velocities and at greater range too. Their prototype launched a projectile in 2022, hitting a target 155.3 miles away. However, it is not known if they have been able to counter the other drawbacks. News on the status of the Chinese railgun is thin on the ground, but their focus on hypersonic missiles may give us a clue as to the project status. What about a handheld railgun? A startup called Arc Flash Labs is selling a $3,750 handheld railgun. The company claims that its GR1 Anvil is the world's first handheld Gauss rifle, a type of weapon that uses electromagnetic coils to accelerate projectiles to extremely high velocities, also known as a railgun or coil gun. Arc Flash co-founder David Worth said, "The GR1 is a potentially lethal weapon, similar to a high-power PCP air rifle." Arc Flash has boiled the concept of the railgun down to a much smaller scale. It says its futuristic, battery-powered handgun is the most powerful coil gun ever sold to the public. Let's see how this innovative concept develops further. Thank you so much for watching our video, and that's all for today. We will see you next time.